Yes, in the previous video, I promised that I will teach us how to differentiate or how to identify organic compounds from inorganic compounds. Let's see. Now, I said organic chemistry studies living, non-living matter present in living matter. That was olden days definition. But nowadays, we define organic chemistry as a branch of chemistry that studies carbon and its compound. Organic chemistry studies only carbon and its compound, but not all the compound of carbon, not all the compound formed by carbon. So excluding two kinds of compound, excluding oxides of carbon, like carbon 4 oxide and carbon dioxide. Those two are not studied under organic chemistry. They are studied under inorganic chemistry. This is CO2 and CO. These two are known as oxides of carbon. They are not under organic chemistry. And then carbonates of carbon, carbonate, like CH2CO3. CO3 is known as carbonate ion. That's triisocarbonate 4 ion. So anytime this carbonate combines with any compound, we can have Na2CO3. This is sodium triisocarbonate 4, and this is triisocarbonate 4 acid. Both are also studied under inorganic chemistry. Now, apart from all of this, every other compound of carbon are known as organic compound, and they are studied under organic chemistry. Now, if they ask me to define organic compound, I will just say organic compounds are compounds that have carbon and hydrogen bond. They have carbon and carbon hydrogen bond. Say it like that. Carbon hydrogen bond. Yes, example of such compound are methane, like CH4, ethane, C2H6. So these two, they belong to a general hydrocarbon family called the alkanes. Alkanes. This is the general formula for the alkanes. CnH2n plus 2. So you can see that there is carbon hydrogen bond. How do we form the bond? See, for methane now, we have we have hydrogen bonding with carbon covalently. Carbon bonding with hydrogen. So all organic compound will have this kind of a bond between hydrogen and carbon. So this is how it happens. It happens like that for alkane. It happens like that for alkanes too, that conform to this general formula, CnH2n. This is the general formula for the alkanes. Then we have the alkynes that conform to this general formula, CnH2n minus 2. All of these are organic compound. And then, in short, alkane, alkene, and alkyne, they are called hydrocarbons. And they are called the aliphatic hydrocarbon because they form straight chain, just like I represented it now. Straight chain. Then we also have the aromatic hydrocarbon like benzene, which is 6,6H6. This is also a hydrocarbon because there is carbon hydrogen bond in the bonding of benzene. So apart from that, we also have some impure hydrocarbons like sugar, glucose, that's C6H12O6. This is also this is also an organic compound, even though it is not pure. It is not a pure hydrocarbon because every hydrocarbon will have only carbon and hydrogen. No more, no any other element attached to it. But this one is impure. If we look at ethanol, C2H5OH, this is also another organic compound. So it contains carbon hydrogen bond, even though it is not pure because there is another element running into it. It is not a pure hydrocarbon, but it is an organic compound because of the carbon hydrogen bond that we have. Now, how do we now know inorganic compounds? Inorganic compounds are those compounds that do not have carbon hydrogen bond. If you don't see carbon hydrogen bond in them, so they are called inorganic compound. For instance, H2O, which is our water, is inorganic. Salt, the table salt, NaCl, no carbon hydrogen bond here. No carbon hydrogen bond here. Limestone, CaCO3, which is limestone. There's no carbon hydrogen bond here. All of these are inorganic compound. H2SO4, which is tetraoxosulfate 6 acid, is also an inorganic compound. So we can also have H2CO3. Look at this. This can create some confusion, whereas it shouldn't create any confusion because I have explained it before. So this is carbonates. So the presence of carbonate in it, even though we have carbon and hydrogen bond, but because this is carbonate, so carbonate is studied under inorganic compound. So under inorganic chemistry, so this is an inorganic compound. It is not an organic compound. We have many other inorganic and organic compound. We can see a lot of many more examples from textbooks. This is a simple way to differentiate between organic and inorganic. So if a student can first overcome this challenge of knowing compounds, different compounds, like how do you differentiate between acid, base, and salt, chemistry become easy. How do you differentiate between organic and inorganic compound? How do you differentiate between ions? How do you differentiate between substances? So you have overcome little part of chemistry like that. Thank you for viewing this. God bless you.